So I think now we can start. Maybe other people will connect, but we discuss only about, let's say, GenMind for the moment. Okay, let's the speaker today. We are Massimo and I. So Massimo is our product manager in German International, many experience in technical support, and it's a very long experience in electronic, say, products. Is really our sponsor for assistance to the customers, and the product manager is also the, let's say, the point of connection with our R&D department. So everything will be that is, let's say, posed to him as question. It is also maybe could be an idea for the R&D department. Real experience is also factory safety engineer. Myself is Andrea Speror, I'm a global account manager in the GMI. Was responsible till this year also for European market. And let's say my experience comes from machine automation. Now I move to the process applications and hazardous side applications. We want to introduce a little bit shortly what is GM International, which is an Italian-based company that produce critically safe solutions and seal certified devices for application really key sector like oil and gas, chemical, petrochemical. We have a really long track history application in DCS, FD application, really critical applications related to the hazardous area and the safety applications. With the 40-year experience, we founded in 1993, and we have complete internal production in Milan, but we have a global presence in two continents through our offices. This is the part of our product. So we produce IS barriers or isolators, safety relay, which is the part of today. Isolators for non-IS application, safety power supplies, multiplexer, termination boards for DCS applications, hard multiplexer, surge protections, indicators, and also we provide factory safety and XEX trainings and services. We want to, let's say, spend a few words about our certification, where we have a product that has been certified from different accreditation bodies. And of course, the company is also certified factory safety management and systematic capabilities. We invest a lot of in our R&D new product, research and development, and also we provide 5 years warranty for all our products. This is let's say a few words about the production. So we produce, as we said, in Italy. We have a complete traceability, full testing, and a really automated manufacturing process. This is our numbers, so 10 different subsidiaries in the world, different distributors, local distributors, high value distributor, I would say. 200 people, total staff. We provide also functional safety engineer course, as we said earlier, all continents. Also, we try to organize also this year, next year, also, so despite the situation with the COVID. That is the number of installation. This is the number, that's in the name of a major customers, divided by system vendors, EPC, OEMs, and the users. So we wanna go now immediately to the topic of today, but first there is, let's say, a poll. We wanted to have your opinion on that. What kind of relay do you basically use? If they are standard or smart or maybe both? I would say that most of you maybe use both because you are in this webinar probably. So you are faced with the standard relay, but we are looking for safety relays. Yeah. Give 1 minute for voting, and then we go to the topic. Okay, no further answer, so I can stop right now. Please stop voting. I want to show you the results. So most of you use say both solutions, standard relays and also smart. Okay, that's fine. So now we can go to the topic of today and with Massimo introduction. Thank you, Massimo.
Thank you, Andrea, for your introduction. And we can start with our presentation. We, we can say that the scope of today's presentation is to specifically present smart relays and their field application based on the experience collected by GM International over years. But what are the specific points of today? In the first point of our presentation today, we will discuss what are smart relays and what are the specific model of the GEM International portfolio. Okay, well, what are smart relay? The smart relay is a relay that guarantees a specific safety function like a typically safety relay, but in addition, it has the ability to perform a complete field diagnostics. For complete diagnostic, we mean a diagnostic that includes complete constantly monitor of the line and the load function in both operating condition of the relay, on and off status. In fact, the diagnostic of a smart relay is able to monitor the functional parameters of the field devices and the line, both to know in the real time the health or status of the loop in the condition of low energization, and as a predictive function to know whether in the event of a request for intervention, the device in the field will activate correctly. Uh, this is very important, especially in a fire and gas safety system. We can say that smart relay combine the basic functionality of safety relay with a complete line and load diagnostics. Well, specifically, we will take as an example the most complete of GEM International smart relay range called the 5294S. This model will onboard the most complete and fully programmable diagnostic circuit. This model is suitable for both normally energized and normally de-energized loads, with the possibility of completely configuring the diagnostic section. When used with the normally energized load, under normal conditions, the contacts are closed. They open on demand to bring the load to its safe state, load off in this case, for example, a valve that needs to be de-energized. Well, the particular composition of the internal contacts arranged in a matrix consists of two contacts in parallel with each other, plus two other contacts in parallel also with each other and placed in series with the load. Andrea, I don't see the presentation to carry on. Okay, next. Next again. Okay. Okay, thank you, Andrea. And we can say before, plus the other content parallel also with each other and placed in series with the load. Makes the D5294S robust to a single relay fault. In other words, even in presence of a single relay fault, while the contact, for example, the D5294S is still able to satisfy the safety function. for example, to open the load on demand. Next again. Okay. In addition, thanks to the content matrix, the D5294X exhibits high availability to the process. If a contact opens by accident, the parallel contact redundancy allows the module to continue supplying the load. The loop is still under service. Next. Okay. Next. Perfect. When used with the normally de-energized load, under normal condition, the contacts are open. They close on demands to bring the load to its safe state. In this case, load on. For example, the beacon light up. Even in this case, the contact redundancy make the D5294S robust to a single relay fault. In other words, even in presence of a single relay fault, contact does not close. The D5294S is still able to satisfy the safety function, for example, in this case, to close the load on demand. The fault of a single contact of the matrix is not sufficient to cause a dangerous fault. Even in this case, the D5294X exhibits high availability also in normally de-energized application. In fact, if a contact closed by accident, for example, due to a vibration, the serious contact redundancy prevents the load from energizing unintentionally. Well, but two different safety functions coexist inside the smart relay. The first one, and also the main function, consists in the input to output or coil to contacts activation deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. The second one is the diagnostic function. It provides full measures, voltage, current, resistance, earth leakage in some cases, of the load, also through Modbus protocol, and it can activate, deactivate two fault dry contacts. The smart relay is equipped with the fault relay, and any anomalies can be acquired through the Modbus protocol. The smart relay is also available for installation in hazardous area, to be precise in Zone 2, Division 2. And we can also say that the main function, coil to contact, is certified seal-free, while the diagnostic is certified seal-2. But let's analyze the diagnostic section of this smart relay, checking what this functionality allows us to monitor. The smart relay is able to detect a line and load fault, both in the de-energized and in de-energized relay condition. What can we monitor when the relay is in the on state? For example, a typical application could be the monitoring of a normally energized valve. Well, when the load is activated, the D5294S is able to monitor continuously the voltage applied to the load, the current flowing through the load, and also the internal coil integrity. This specific model of smart relay has the possibility to perform an internal diagnostic of its coil, and in the event of a fault, report this fault to the system. Well, what can we monitor when the relay is in the off state? typical for fire and gas application, where we need to know the health of the field load. When the load is deactivated, the D5294S is able to monitor continuously the power supply voltage of the load, the impedance resistance of the load, the leakage from the load to the ground. In this case, the relay can monitor the leakage resistance between the earth and the load. Let's see now specifically how the relay can communicate with the system. How and what are the ways in which a smart relay can communicate with the safety system? Smart relay can report the field status to the system in several ways. For example, the two-fault contact can be acquired by a system digital input card. This is the typical way, which implies the use of a DCS with a dedicated digital input card, where the status of a contact, called a fault, is monitored by the system. The second method could be if the system digital output card driving the smart relay support pulse testing. The fault in the field can even be mirrored directly to the digital output, without the need of an additional digital input card. This feature will be investigated in more details later. Another feature is complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol, if a Modbus master is available on the system side. Remember that through the Modbus protocol, the relay can be constantly monitored and also configured remotely. And again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative report from many modules is required. But the second point of our presentation today is what are the reasons that make us prefer a smart relay to a standard safety relay? Why going for a smart relay? Nowadays, full diagnostic is typically required along the full loop. However, many widespread systems do not support diagnostic inside their digital output card. Smart relay make diagnostic available to systems that do not support it. Many modern systems do support digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliampere at 24 volt DC. Or other case is when the load, valve, beacon, sound, etc. require more than 24 volt and or more than 500 milliamperes. Relay are necessary. And yet, when using standard relay, the digital output diagnostic pulse testing dies at the relay coil and cannot reach the load in the field. As opposed to that, smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostic. Even if modern systems can perform load diagnostic, their capability may be limited. For instance, air leakage monitor may not be supported, or extreme load, for example, beacon, may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capabilities. Well, in the next slide, we will see smart relay may offer a solution to extend the digital output diagnostic capability. In this slide, we briefly see the models and diagnostic capability of the GM International relay seen so far. In the following slide, we see in the ascending order of diagnostic functionality a series of GM international relay, all idly available to the process. From the D5094S, D5095S safety relay without field diagnostic, but with high availability to the process, thanks to the internal contact metrics. The D5096 and 97S smart relay effective cost, which combine a complete load and light diagnostic with preset value, and finish to the series of fully configurable smart relay with the possibility of Modbus communication, detection of an internal fault relating to its coil, and monitoring of the earth load leakage resistance. Let's see in more detail what is the mirroring function on a smart relay. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC. This function is for both in the off status through the pulse test system and the on state of the relay by reading the static return of current. The digital output card of PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuits, allows us to the supervised digital output to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose. Well, Andrea, we have another call before to start with the presentation, the real application of the smart relay.
Yes, if you can answer to this last question. Thank you.
Okay.
If you would say it's clear for you something, some features that we explained, Massimo explained earlier about what we are on.
Two questions from our attendee.
Exactly. If you can answer now, let's wait the finishing the
Okay,
poll and then we continue. Okay, don't see further answer. We can stop for now. Thank you for voting. I want to share with you the results. So the winner is mirror on the off card. So it means that it's very important features. And we will show you also later on the real application where we apply also these features. And Massimo, indeed, there are two questions from the attendees. One, how the line and the load diagnostic will work in case of normal de-energized loads when contacts are open? That's a good question. So,
yes, question. But the smart relay is able to provide a complete load and light diagnostic even in case of normal de-energized application. This is possible because the smart relay sent versus to the field, the load as molt current and read this allows to the relay to read the impedance of the load and the health of the line.
So there are some limitations, of course, when the contact opens. You cannot check all parameters. You can check when the contacts are closed.
Yes, and this parameter in some cases, for example, the 5294S is totally configurable.
Yeah. Okay, so we see also this point later about the configuration for the smart relays. The last question is, some safety system also has diagnostic pulses on the odd channels, right? Is it possible that the relay can be transparent for PLC diagnostics so that any line fault in the field can be seen on the PLC instead of the relay? That's another good point. So it means that for the these
Yes,
are talking about the pulse testing, right?
yes, the smart relay allows us to perform a complete load and light diagnostic from the digital output card up to the field device. This is possible because the smart relay usually are compatible with the pulse test system of the various PLC system, and the smart relay is able to perform the complete field diagnostic both in on and off relay condition.
Yeah, the point also is that any single pulse testing coming out from the
Yes.
PLC DCS cannot be go through the relay. It
Yes.
will be always, say, filtered. It will always be limited to the relay because there is a really mechanical and electrical division between the circuits. So the only point is that the relay, that if you use our relay, another relay, that relays shall be, say, compatible with the bus net. Otherwise, your output will flicker every single time. So it will damage the load, it will damage the relays, the positive relay. So it is a problem. Of course, the pulse testing is good if you are using straight to the load, but in some cases not possible because we have seen that there is a limitation on the power out, there is a limitation on the connections, and a lot of limitations. And when it's not possible, use safety relays, but the pulse testing from the PLCs cannot go through in that case to the load. Okay, yes, I remind you that chat is disabled. You have to use a Q&A button if you want to make any question to us, as the two attendees already did. We'll go through now the real application, so real world application is my part. And we are talking about normal energized solenoid valves, throw beacons for firing gas application, dual tone sounders for firing gas application also, high availability double coil solenoid valves, single phase load interaction solenoid valves. So in this case, application are here, so there are really, say, normal application where the solenoid valves are the most common. Of course, there are strobe beacons, mainly for firing gas application. And also there are dual tone sounders for firing gas application, so dual tone. And in this case, we have also application for solenoid valves with the dual coil inside for high availability. And the last is single phase load interaction. So in our say world of application in the years, we did a lot of specific solutions. So with the most common, most reliable, most known DCS system and safety PLCs. In this case, you see that there is an application where we are using an Emerson Delta V system for safety, and where there were some valves to be driven through the DCS. In this case, for the PLC, in this case, as we said, you could not drive it back because of the impedance, because of the power and so on. So there are different possibilities, and one of that is using the data safety relays, 5294 or 5096S. And this is of course, the situation where you have power supplies, which is powering the system. The PLC is driving the load to the relay, and the diagnostic is coming out from the relays to the system. And this is the application. So normally is we have a normal energized valve. So non-valve means that this is the offline state. The normal condition is a normal energized, so the system digital out is acting, is closing the system, and all the relays in you have seen that inside that relay there are 4 relays in parallel, 2 parallel in the series with the load with the other 2 relays in parallel. So it's a really sophisticated architecture, but there is a reason why they've seen, because of safety and availability too. And so this is the normal condition. So everything is going in the proper way. So the safe state means that the system DO will open. So I will decide to retrieve the command. So it will stop, the flow will stop flowing through the valve. And so coming back to the normal condition, but in the normal conditions, I can have some fault. And one fault is when my circuit for the load is opening for unwanted situation. So I have a problem that my circuit, my wiring will be, say, will have a problem. So I can detect immediately that fault that will be reported to the digital input system. And the digital input means that on the PLC, the Emerson PLC, Delta V, can detect immediately that there is a problem on the load. I see that this is the features that I can have with the 5096S because it has not a Modbus capability, but the same I can have with the 5294, and this fault will be detected through also Modbus communication. It is an additional feature, so through Modbus you can have multiple relays connecting the same line, and I can have detection of what problem I have in my circuit now. I can have also another detection, which is the short circuit. So the short circuit will be immediately as well reported to the safety system through, as I can see through this 5096S relay, I can detect the fault through a digital input. But if I use the 5294 for the same condition, I can have the information through Modbus. The difference between having a digital input information or having a Modbus is clear because I think that you can understand here, I can have, if I use just a digital input, I can have the same, say, information, fault information that on my load, on my application, but is a generic information. I know that there is a problem, but I cannot discriminate if it is a short circuit or an open circuit. While Modbus can give you much more information. You can have different registers, different information, exact information about the problem. So you can know that you have a load, an open circuit or short circuit. So the information is different because the register is different. That is the main difference between Modbus and digital input. So this relay can also, of course, detect the power supply problem. So I can detect that there is a disconnection from the power supply, and it will be reported to the circuit through a digital input in case you use the 5096S and use 5294 as, of course, it will be Modbus. The customer in this case decided to use both because there were there were a lot of relays in the application, and they decided to use few with Modbus, few with others. course, we have the possibility to, yes, the possibility to choose and keep it. And let's continue because I can have another important information for you, which is the internal coil fault. So we know that also our relays can have a fault that are good relays, but not perfect, of course. So I can have one relay out of 4 relays that is having a problem, and this can be also reported to the system. You see that I don't I not have any bad effect on my application because the system is still working. I have no problem by my flow, so its valve is activated, but I know that there is a fault on one relay. So this information is crucial because I know that I have to repair it or replace the relay without, let's say, having, let's say, or losing my availability. We can stop here because I see a lot of questions for you. So we wanna answer first on that because there are a lot. So the first is, does the relay need a separate input power for its operation?
Yes.
Massimo?
Yes, smart relay needs to have two separate inputs. One for power the diagnostic circuit, typically with the voltage 24 volt. And another input is from the digital output card, and even in this case, 24 volt.
Okay, this we answer. The next one is, of course, is for you. Is there any overload protection in GMI smart relays?
Yes, on the output of our smart relay special for the 5294S, we have foreseen the resettable fuse internal on the circuit output of the relay. This fuse have the possibility to interrupt in case of short circuit and reset your condition when the short circuit is removed.
Okay, next question is, can you show typical wiring drawing for relay having a load at 230 VAC with the O from PLC at 24 volt DC? We will see later because there is one slide for that.
But in this case is maybe the case we answer to the attendee via mail, but on our instruction manual is possible to see the typical connection from the relay, but we can see that usually for the 230 volt AC, the earth connection is not involved in the wiring, the relay wiring, but usually we can interrupt the line and the neutral of the power supply voltage.
Okay, fine. This is three questions, but there's only one from attendee about Modbus. Can we issue a broadcast message from Modbus master? So we have an application where we have different relays connected with Modbus. And the attendee is asking, this Modbus master device that is, of course, the PLCs, is able to switch off all relays through one command, through a broadcast message.
Yes, Andrea. Via Modbus is possible to give a command to the relay for
turn off, turn on?
turn on and turn off the load. Yes.
Okay. So we answer to this and this. Okay, fine.
And of course, the Modbus is not seal certified and safety reader certified.
Exactly. But is not interfering with the main safety function, and we can have these two situations within the relay.
Yes.
Okay, let's continue with the presentation. There are others presentation that is has been done with S800 DCS from ABB, and this is an application with the beacon strobe. So it's always the same. So I don't want to, but we have only one slide that resume everything. And in this case, there is for firing gas, so the normal de-energized situation. And I can have, as the other previous, I can have different detectable fault, like power supply fault, open short circuit, earth leakage. It's also one other important um, fault I can detect, and also internal coil fault. So a coil for the our relay. Those are the information I can detect also for the beacon or strobe for the, say, lamp you have on the field for firing gas application. The next one is with the Foxborough DCS, Lacard FBM 200. And in this case, there is a sounder. In this case, sounder for always for firing gas. I have the same situation. And this is a dual tone sounder. So I have a dual tone because it's information is a different dual tone because of different alarm. And we have solved this situation with the two relays. And you see it's a really complicated situation, but I can have as well, I can connect my load to the sounders, which is will be activated two different ways from two different contacts. Also, in this case, detectable fault at the power supply, open short circuit, internal coil fault. I repeat, only if we use 5294, 5295, the two products are really top relays from our catalog. And the 5096, as is explained here, is not do not fulfill that functionality. So we have another application which is also very interesting with the ProSafe RS from a Yokogawa system. And in this case, we have a double coil solenoid valve. A double coil solenoid valve is very important in the large industrial compounds where you have the coil in the valve, which is double. So you have only one coil is sufficient for the valve to be activated. Okay, so there is a say that is a valve with high availability because there are two, as I said, two solenoid inside. What is the important thing for having that is that beside the normal fault that we can detect through the relays we have seen as in the other applications, here I can detect also the fault on the coil for the valve. That is very important because if I can detect the failure on the coil, I can be proactive on my maintenance. I can, let's say, decide to stop anytime when it's possible to replace or to repair my valve because I have one coil which failed. And this is the further very important point because beside the internal coil, our relays coil, we can detect also the coil for the valve and let's say be proactive on maintenance. The last one is the Honeywell DCF C300, and here there is a thing that this relay is also possible be connecting by single wire. That is possible because of a low power, let's say, consumption load, in this case because it's just a coil. And so we can go directly from the relays with only one wire to the valve. And again, I can have, let's say, can detect any power supply, fault, open short circuit, internal coil for the relays. And also I can have a Modbus interface as a detection system. Let's see, I don't see further question. We didn't finish yet. We have a few more things that Massimo can explain you. So,
Yes.
Massimo?
Yes, thank you, Andrea. What we can say about the software configuration from the Smart Relay, the D5294S or the D5295S can be also configured when the parameters to be monitored are real specifics and the alarm trigger is not achievable with standard monitor relay. It's also possible to monitor the status of the loop in real time with the configurator. And again, through a dedicated software called SWC 5019 and a small hardware interface, we can completely configure the module. For example, we can set up a window in which the value of the voltage of the load, current flow in the load, and impedance of the load are included. In this way, when the measurement of the variables in the field come out of this window or the configurator value, an alarm is reported to the system. And through the configuration software, it's also possible to read in real time the value of the voltage, current, and the load impedance. A first example is what we see in the slide where an impedance solenoid valve of about 100 ohm is monitored together with its current. In this specific case, the failure of a coil inside the relay causes redundancy to be lost, but the relay signals the anomaly while still maintaining the energized loop. This is possible thanks to the contact method inside the relay, which guarantees us high process availability. In large industrial compounds, raffinery, etc., double coil valves are normally controlled by a single digital output driver. The double coil avoids fault trips, keeping the system active even if one of the two fails. In this context, the D5294S is again an optimal solution because it can detect the opening of the single valve coil. It's providing predictive diagnostic for prompt maintenance while keeping high availability. In the next slide here, we have the example of monitoring on an fire and gas system, where a partial short circuit affects the winding of the solenoid. This is the typical case where the setting of a specific threshold within which the load impedance value must fall can be monitored. When the impedance value falls outside the set value, an alarm is detected. Note that the 5294S can set an impedance value between 5 ohm and 50 kilo ohms. And
yeah, there is one indeed just let to the attendee know that there are a lot of applications where the standard relays cannot be applied because if you wanna really monitoring some values you see here, say you wanna set exactly values of resistance to be monitored and so on. Normally, especially if you're using some beacons, some horn, some light, those values are really, let's say, different each other. And only if you use configurable relays, you can solve and detect exact values for alarm, not detect maybe cause unwanted alarm because of, say, strange values of the impedance. Okay.
Okay, thank you, Andrea. Now we can talk about an important characteristic of the smart relay, that is the Modbus. The relay modules D5294S or the 5295S support Modbus communication over an RS485 cable. Up to 127 modules can be arranged in a multi-drop network and monitored, configured by a single master unit, as shown in the following picture. Each slave contains a table of parameters. Each of them is univocally identified through an address, and when requested, makes available its value for reading and writing. What are the advantages of using Modbus communication? Well, with a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input card system to monitor alarms. This allows us to have a significant saving in terms of cost for our application. And again, real-time information on the type of alarm and on the health of the load and the line can be monitored. And it's also possible through Modbus, a complete remote programming of the relay. Well, we have finished our presentation. I leave to Andrea for the conclusion.
Just conclusion. So we just to remind you that we have a point-to-point contact SIM3 tube certified for the relays. 5294, D5295 have a complete load and diagnostic capability, which is certified for J2. It means that you can also configure voltage on load, current on load, load resistance, that is a patented features. You can configure the leakage from load to current, the coil integrity, and internal fault. While other D5096S, D5097S have load and line diagnostic capability, like a load line open short circuit, load open short circuit, load supply presence. There is a Modbus RTU interface only for D5294S, D5295S. There are all of them are compatible with the digital output card line monitoring pass testing. So it means that they are not, the pass testing is not interfering with the functionality for the relays. And the last one is the fault mirroring to the DO card, which is a quite nice features that save a lot of digital input card in case you use different relays on your system. So we almost finished. Let me see. There is the last question. Is it possible to configure relay through Modbus?
Yes, absolutely. It's possible to configure all parameters of the internal diagnostic of the relay through the Modbus. All parameters can be configured, and the writing through the RS485.
So you can either use our software or Modbus software.
Yes,
So,
we have
okay, we almost finished. We want to ask you the last. Okay, if you want to rate our webinar, it will be very glad. Okay. Until we do, thank you very much for answering. We have other two questions later I want to answer before we leave you.
Yes.
Thank you. We don't show you our, let's say, rate, but thank you very much for voting. You are really kind. And
Andrea,
right.
in the meantime, we wait the attendees to answer with our poll. We have another two attendee questions.
Yeah.
And the first one is, can we save the configuration? Yes, the answer is yes. We can save the configuration on our PC. And in case we can read back the configuration and save the configuration inside the new relay.
Okay. The answer to this. Okay, let's finish here. We want to remind you that our contact details. If you wanted to send us any request, you can write us or phone us, whatever you like. We want to remind you also that this webinar and the other are available on our website for reviewing. There is a YouTube channel, so you can see this webinar and the others that have been recorded. There is also the calendar for the next webinars. And if you want to make any other webinars you think it can be interesting for you, for your company, you can ask for also on-demand webinars. Again, thank you very much to you. Thank you very much, Massimo.
Thank you very much, Andrea. Thank you to our attendees.
Let's see you soon. Thank you.
See you the next webinar. Thank you.
Bye-bye.